Hi guys, I am back with a new question. So question is like that: there are two balls of mass m and 2m are given. Mass m and 2m are given, and with the momentum, initial momentum 4p and 2p in direction as shown in the figure. Okay. During collision, the value of linear impulse between them is j. The term of in terms of j and p, find the coefficient of restitution. We have to find coefficient of restitution E in terms of j and p. And okay, first we'll try to solve this part and then we'll come to another part. Okay, so this we can clearly see the condition before collision. Okay, so I will draw a plot after collision. After collision, what will happen? This particle mass 2m and m, after collision this m mass will move in this direction with velocity v, final velocity v1. I'll say this particle is particle 1, this particle is particle 2. So v1, and this will move in this direction v2. So and before this, actually when they are colliding, impulse on this will be in which direction? J will be in this direction, and for this particle 2 or 2m, j will be in this positive x, you can say this positive x direction. Okay, so that is what we did up to now. And initially when they are moving, it will have some u1 velocity, initial velocity, it was having u2 velocity. So this thing, is it clear? Okay, so now we have to find that coefficient of restitution in terms of j and momenta. Okay, so what is coefficient of restitution? First tell me. This is velocity of separation divided by velocity of approach. This is our coefficient of restitution that we have to find in terms of j and p. So I'll consider first particle 1, means m mass particle. Okay, so j impulse, impulse is change in momentum, and my impulse is in negative direction. Since this is my positive direction, I will say change in impulse will be how much? Final momentum will be, suppose I am taking p1 is final momentum, so its momentum will be p1 in this direction, and for 2m mass particle, it will be p2 in that direction. But since p1 is negative, so I'll take p1 final momentum minus initial is positive, change will be for change I have putting negative sign, so minus 4p. So from this equation, can I find value of p1? P1 will be equal to j minus 4p. Okay, this is my another equation. So p1 I got. So p1 will be my final momentum. So my final momentum, can I write like mass of that particle into v1 equal to j minus 4p, or v1 will be j minus 4p by m. So this is my another equation. Okay, similarly for particle 2 of mass 2m, can I find change in impulse that is in positive direction? Okay, that will be equal to, final impulse will be p2 and initial will be minus 2p. Okay, so p2 will be equal to j plus 2p, and similarly it can be written as 2m into v2 equal to j plus 2p. So I can write v2 will be equal to j plus 2p by 2m. So this is my another equation. I can give it as a name as equation 2 and equation 3. Okay, so by now we are okay, because we have to find coefficient of restitution, and this is velocity of separation. Okay, so I can again write coefficient of restitution will be equal to, you can write E will be equal to minus v2 minus v1 upon u2 minus u1. Okay, so by now we have found value of v2 and v1, and because we have to find coefficient of restitution value in j and p, so I am finding velocity v2 and v1 in terms of j and p. That is what I found. And now actually we can easily write a value of u2 and u1. you see first case, that is very visible. So for particle 1, okay, here I'll write below this, for to find, I'll write for u1. So because total momentum is can be written as mu into u1, so u1 will be, and it is in a positive direction, so 4p by m. So this equation can be also named as equation 4. Okay. So similarly, okay, going to next page. So similarly for 2m particle, so u2 will be, what is momentum, 2p minus 2p upon 2m. So this is equation number 5. So now we have all the variables. So I'll write what we want. We have v2, that value of v2 is j plus 2p by 2m. v1 is j minus 4p by m, and u1 is having value 4p by m. u2 is having value minus 2p by 2m. Okay, these value we have, so we just have to put in this equation to get coefficient of restitution in form of j and p. Okay, so we have to find value. Oh, one second, actually there is a small mistake in this sign. So for second particle, change in impulse will be p2 minus of minus. So minus of minus means it will be p2 plus 2p, so one negative will come. So at final I can put value of j minus 2p. Okay, so it will be, sorry, j minus of 2p, it will be minus. Okay, so here also I can change, it will be minus. So now I can put the values to find coefficient of restitution. So it will be j minus 4p, that is v2, by 2m, and plus it will be v1. Okay, so because it is j minus 2p by 2m. Okay, negative we already considered, so it will be like this. So now we have to put value of u2 and u1. So u2 is 2p by 2m minus 4p by m. So if we solve this, it will be minus of j minus 4p by 2m plus j minus 2p by 2m by 10p by 2m. So by solving this, E will be equal to 3j minus 10p by 10p. So this will be final value of coefficient of restitution. Now we can move to the second part of the question. What he was asking, under what condition the collision is elastic? Also find the condition for perfectly inelastic collision. Okay, so condition we have to find. We found coefficient of restitution. Now we know for elastic. Okay, I'll change pen. For elastic collision, E will be equal to 1. So I can put equal to 1. So means 10p will be equal to 3j minus 10p. So from this, j will be equal to 20p by 3. So this will be value of g for inelastic. For inelastic collision, E equal to 0. Then I can put 0 equal to 3j minus 10p by 10p. So j will be equal to 10p by 3. So these two are our answer. So I hope you get this problem, how to do this, and this is for today. Okay, thank you, bye bye, take care.